From Milpitas, California, at the edge of Silicon Valley, it's theCUBE, covering autonomous vehicles. Brought to you by Western Digital.
Hey, welcome back everybody. Jeff Frick here with theCUBE. We are at the Autotech Council Autonomous Vehicles event here at Western Digital. It's part of our ongoing work that we're doing with Western Digital about data makes possible and all the really innovative and interesting things that are going on, that at the end of the day, there's some data that's driving it all, and this is a really crazy and interesting space. So we're excited for our next guest. He's Mark DeSantis. He's the CEO of Roadbotics. Mark, great to see you.
Welcome. Thanks for having me, Jeff.
So just to give the quick overview of what is Roadbotics all about.
Sure. We use a simple cell phone as a data collection device. You put that in the windshield, you drive, it records all the video, and all that video gets uploaded to the cloud, and we assess the road surface meter by meter. Our customers would be public works departments at the little town to a big city or even a state, and we apply the same principles that a pavement engineer would apply when they look at a piece of pavement, looking for all the different subtle little features so that they can get first of all, get an assessment of the road, and then they can do capital planning and fix those roads and do a lot of things that they can't do right now.
So I think the economics of roads, the condition of roads in general, right? We don't think about them much until they're closed, they're being fixed, they're broken up, there's a pothole.
Yeah.
But it's really a complex system and a really high value system that needs ongoing maintenance.
That's right. I always use the example of the Romans who built a 50,000-mile road network across Europe, the Middle East, and Africa. Some of those roads, like the Appian Way, are still used today. They were very good road builders and they understand the importance of roads. Regrettably, we take our roads for granted. The American Society for Civil Engineers annually rates infrastructure, and we're rated about 28% of our nation's 11 million lane miles as poor. Unfortunately, that's
28%?
28%. And that really means that we'll need to invest at least $1 million to $2 million a mile to get those roads back into shape. So we take our roads for granted. I'm enjoying this conference, and there's one point that I want to make that I think is very poignant, is the AV revolution will also require a revolution in the maintenance and sustenance of our road network, not just in the United States, but everywhere in the world.
So it's interesting in doing some research before we got together in terms of, you know, the active maintenance that's not only required to keep a road in good shape, but if you keep the active maintenance in position, those roads will last a very long time. And you made an interesting comment that now the autonomous vehicles, it's actually more important for those vehicles, not only for jolting the electronics around that they're carrying, but also for everything to work the way it's supposed to work according to the algorithms.
Andrew Ng, who's an eminent computer scientist, machine learning, we were spun out of Carnegie Mellon, he was a graduate of that program, recognized early on that the quality of the roads made all the difference in the world for these vehicles to move around. We in turn were spun out of Carnegie Mellon, out of that same group of AV researchers, and in fact the impetus for the technology was to be able to use the sensing technology that allows a vehicle to move around to assess the quality of roads. And road inspection really is an important part of road maintenance, the ability to go look at an asset. Interestingly, it's an asset whose challenge is not the fact that it can't be inspected, it's the sheer size of the asset. When you're talking about a small town that might have a 60-mile road network, the vast majority of inspection is visual inspection. That means somebody in a car riding very slowly looking down. Now do that for tens, thousands, hundreds of thousands of miles, very hard to do. Our system makes all that much more efficient. The interesting thing about autonomous vehicles is they'll have the capacity to use that data to do that very assessment. So for our company, we ultimately see us embedded in the vehicle itself. But for the time being, cell phones work fine.
Right. So I'm just curious, what are some of those leading indicator data points? Because obviously we know the pothole, by then things have gone too far, but what are some of the subtle things that maybe I might see but I'm not really looking at?
Well, I think I've changed you right now and you don't know it. You're never going to look at a road the same after you hear me talk for the next 3 minutes. I don't look at roads the same, and I'm not a civil engineer, nor am I a pavement engineer, but as the CEO of this company, I had to learn a lot about those two disciplines. And in fact, when you look at a piece of asphalt, you're actually looking for things like alligator cracks, which sort of looks like the back of an alligator's skin, block cracks, edge cracks, rutting, a whole bunch of things that pavement engineers, frankly, and there is a discipline called pavement engineering, where they look for. And those features determine the state of that road and also dictate what repairs will be done. Concrete pavement has a similar sort of set of characteristics. So what we're looking for when we look at a road is, I always say that people say, well, you're the pothole company. If all you see are potholes, you don't have a business. And the reason is potholes are at the end of a long process of degradation. So when you see a pothole, there are two problems. One is You can certainly blow out a tire, break an axle in that pothole. But also it's indicative of a deeper problem, which means the surface of the road has been penetrated, which means you have to dig up that road and replace it. So if you can see features that are predictive of a road that's just about to go bad, make small fixes, you can extend the useful life of that asset indefinitely.
Right. So before I let you go, unfortunately, we're short on time. I'd
Yeah.
love to learn more about roads. I told you I skateboard, so I pay a lot of attention to smooth roads and rough
you'll pay
roads.
even more now.
Now pay more and call the city. But I want to kind of pivot off what happened at Carnegie Mellon. And, obviously academic institutions are a huge part of this revolution. There's a lot of work going on. We're close to Stanford and Berkeley here. Talk a little bit about what happens happening at Carnegie Mellon. And I think specifically you came out of the Robotics Institute and something called the Traffic 21 project.
Yeah, Traffic 21 is funded by some local private interests who believed that the various technologies that are really CMU is known for around computer science, robotics, engineering, could be instrumental in bringing about this AV revolution. And as a consequence of that, they developed a program early on to try to bring these technologies together. Uber came along and literally hired 27 of those researchers. Argo Ford's autonomous vehicle now, is big in Pittsburgh as well. On any given day, by my estimate, it's not official estimate here, there are about 400 autonomous vehicles, Ford and Uber vehicles, on Pittsburgh streets every single day. It's an eerie experience being driven around by a completely autonomous Uber vehicle, believe me.
I've been in a couple. It's interesting. Then we did a thing with a company called Phantom. They're the ones that step in if your Uber gets stuck, which is interesting. So really interesting times and exciting. And I will go and pay closer attention for the alligator patterns on my route home tonight. All right, Mark, thanks for stopping by and sharing the insight.
Appreciate you having me.
All right, he's Mark. I'm Jeff. You're watching theCUBE from the Autotech Council Autonomous Vehicles event in Milpitas, California. Thanks for watching.